In this lesson, we are going to introduce some basic properties of logs. A log. Biggest thing about a log is an inverse of an exponential. So everything has a do and an undo, like squares and square roots go together, they undo each other. Adding and subtracting go together. Multiplying and dividing go together. Well, logs undo exponentials. So if you're going to solve some sort of an equation that's an exponential, most likely you're going to use logs to solve it. And if you have a log equation, most likely you're going to use exponentials to solve it. So here's kind of one of the biggest things is if you have an exponential, you can rewrite it as a log. And so the base of your exponential becomes the base of your log, and your exponent becomes what it equals. So logs equal exponents. So the base of your exponent becomes the base of your log, or the base of your log becomes the base of your exponent. And then if you're going this direction, it's the base of your log equals the base of your exponent. Logs equal exponents, so that value becomes your exponent, and then it equals x. So you can go forwards and backwards with them, and we're definitely going to be using that as we go through not so much these, but definitely future problems. So some of the properties we have is if you see a log, almost all logs have bases on them. If it's not there, that's because it's kind of an implied 10. So that's kind of button that you'll see on your calculator is it doesn't have a base on it. That means it's base 10. If you see this one, this ln means that it has a base e. So ln is a base e. So those are the two different logs that you just have openly on your calculator. There is a way, depending upon the age of your calculator, where you can create whatever base you want. And if you can't, then we have a workaround for it. So let's see. Two big things about logs are logs don't keep exponents. So if you have a log problem that has an exponent on it, then you can pull it in front, and then it just gets multiplied to the log. That's going to be a very, very key thing when we try to solve exponentials. And then log base a of 1 equals 0. And the reason for that is, going back to this, if you take the base of your log, you could rewrite this as a, and logs equal exponents, a to the 0 equals 1. And that's a true statement because anything to the 0 equals 1. And then this is one of your biggest ones, at least on some of these properties that we're going to be doing down here, some of these problems, is log base a of a. So if the base matches the number, it equals 1. And it's because if you take this and rewrite it, the base of your log becomes the base of your exponent, and then raised to the first power. Does that equal a? Yes. So when those two match, they equal 1. So these two combine together with the base match and the number here. That and the fact that logs don't equal exponents is going to be what we're going to use to simplify all of these. So all of these are meant to be non-calculator types of problems. And then down here, natural log of 1, which is log of 1, anything of 1 is going to equal 0. And then here it equals 1, just like this property, because remember that the natural log is really a log base e then of e. And if they match, you're going to equal 1. Okay, so here's how this goes. If these are non-calculator types of problems, we are looking to rewrite this. And not so much like this, we're just going to rewrite this so that I am looking for this type of thing to happen. That if this base is 10, most likely if this is a non-calculator, it's a whole bunch of 10s. So 10,000 is 10 to the 5th. And here's where these two properties are going to kick in. Logs don't keep exponents. So then I could bring that 5 in front. And then all I have left is this, and log base 1 or base 10 of 10 is this property right here. So this piece is just going to become 1. So it's 5 times 1, which equals 5. So if you were to type that into a calculator, you would get a 5. And it's all about exponents. All right. So this one's a little bit trickier. It's the fact that 0.1 or 0.01 is equal to 10 to the negative 2. If you remember kind of your scientific notation, moving the decimals back, So you could rewrite this as log base 10, so that's always my goal on the non-calculators, and figure out what my exponent is. Property, or the exponent comes in front, and then this piece is equivalent to 1, so then you just get a -2 out of it. So here, instantly I'm thinking I'm going to rewrite this as 2 to some power. And again, non-calculator is meant for this to work out. So 2 to some power is going to get me an 8, and 2 to the third is going to make that happen. Bring the 3 in front. And then I have this property where that just becomes 1. So then I get a 3. All right, we'll do one more and we'll do the others on a different video. So this one is, don't forget that that's an implied 10. So that is log base 10, and 10 to the second is going to get you 100. Pull your 2 in front. That's going to get you a 1. So this is multiplied together and get you a 2. All right, and then we will continue the rest in the part 2 of this video.